Lesson 23, student page 127, solution sets to simultaneous equations. Now remember, we're not going to worry about this word simultaneous. It means more than one, and it means occurring at the same time. So let's look for our critical information. Here's a system of two linear equations. Here's the first linear equation, and this is the second linear equation. And they've named them A1 and A2. It says verify that the solution to this system is 3, 4. So what we really know from this, if we know that the coordinate of the solution is 3, 4, what it's telling us is something that we should already know, which is that x is equal to 3 and y is equal to 4. Since we know this, we could, we could say, oh, these two are equal, so this is equal, or we could just simply put it in. So in A1, system A1, equation A1, we would put in 4 for y and 3 for the x and add 1. And ask ourselves, does 4 equal 4? And check yes. So 4 does equal 3 plus 1. In equation A2, we have a similar situation, only this time, well, y is still 4, right? But this time, we're going to do something a little awkward to this. We're going to say -2 times our value of x, which is 3, and then add 10. Is adding 10 enough of an adjustment to get this to be true? 4 equals -6 plus 10. And again, indeed, we get 4 equals 4. So the fact that we can plug in both 3 and 4 into both equations, the fact that we can make this happen is all the evidence we need to prove that 3, 4 is a solution to these two simultaneous equations. So now we're going to do some experiments. It says write down another system of two linear equations whose solution is 3, 4. This time make sure both linear equations have a positive slope. So if we look up here, what we see that indicates to us whether or not we had a positive slope is right here. Remember, this is in y equals mx plus b order, and we can see this one's positive, but here we have a negative, and that -2 is what's telling us it's going down. So that's something we're going to have to take care of. And we're going to do it this way. What we're going to do is we're going to say, okay, still need 3, 4. That means y is going to equal something times x, and y equals something, some mystery thing times x, plus some kind of adjustment in order to make it work. So just for the fun of it, let's see, we know y is 4. Y is going to be 4 on all occasions for this. So we're going to say 4 equals, and I'm just going to add, we know x is 3. Now we can set this up for both of these, plus something, or times something plus the adjustment. And we're supposed to come up with two linear equations. So we're going to call this B1, just like we have up here. And then I'm going to create a B2 with the same thing, B2. And we're going to say again, 4 is going to equal something times 3 plus something. And we're going to figure out what that is in a minute. Now, it said that we had to have a positive slope, so if we're going to keep the slope positive, that means I'm going to have to put some number like, well, I could put 2 in here. I mean, we know that. And that gives us 4 equals 6. So 4 doesn't equal 6, but 4 could equal 6 if we subtracted 2, right? So if we subtract 2, we get 4 equals 4. So that did yield an equation. We just have to unravel what that equation is. And that equation is, now we're going to replace this back with the y and this with the x, because now we've done it and we see that our new equation could be, our first one, B1, could easily be y equals 2x plus -2. And that's excellent. I'm very happy with that one. All right, so we got the same process here. We have to keep it positive. So I'm thinking about, I already used 2. I don't want to use too big a number, but, well, okay, so I'm lazy. We're going to use 3. Why not? All right, what does that give us? that gives us a new situation. Let me get another color because I can see I'm about to have a mess up here. And we're going to have 4 equals 9 plus some adjustment. And the only way 4 can equal 9 is if the sum adjustment is minus 5. So we'll make that minus 5. Now remember, we went back in, we said let y and x now become just y and x. Y and x. So what we come up with, we have B1, like our B1, and now I'm about ready to write my B2, my official B2. Whoops, I guess I should make that a 2. B2. Wow, that's a really scroungy looking 2. Oh well. Y equals 3x plus negative 5. So there we go. It says verify that the solution to the systems of the two equations is 3, 4. Well, we're going to verify it. We've already verified it. We worked backwards and we got it. But in B1, we can say 4 equals 2 times 3 plus negative 2. 4 equals 6 minus 2, 4 is 4. Check. In B2, we get 4 is equal to 3 times 3 minus 5. 4 equals 9 minus 5. And that also is a truth. So we know then that 4 equals 4. Okay, that wasn't so bad. All right, I've set up the graph and it asks us to graph B1 and B2. I'm going to go ahead and graph these, and remember we're going to start here with the B, which is the begin here, and then we're going to use this for our moving. So anyway, I'm going to begin at negative 2, and I'm going to put points. Let me put some points here and there so we can find. B is at negative 2, and then my slope is up 2 over 1. And I like to do several up 2 over 1, up 2 over 1, up 2 over 1. And that makes where my line is going to go reasonably obvious. So now we'll go ahead and we'll add the line. Line is negative 5. So we're going to begin this one at negative 5. So we're going to go to a slightly different spot. So if that was negative 2, negative 4, here is negative 5. And what did I do? I probably picked the same color. So let me find a different color. Oh, purple. We love purple. I love purple. You guys like purple too. I tell you, you're going to. And the slope is still, this slope is different. It was negative 5, but the slope is 3. So it's up 3 over 1, up 3 over 1, up 3 over 1. Oh, yay. That is a very nice feeling when that happens. Up 3 over 1, and I'm going to go ahead and get one more on here because it makes my graphing so much easier to have enough. Up 3 over 1, there we go, lamba. So let me go ahead and cast this line in here through this dot. Okay. Well, it's going to be reasonably close, but there we go. All right. I didn't aim very well, sorry. But here we go. There's our two lines, and the big question is, does it intersect? Is this point here, is this lovely point here the one we want it to be? And if we look, it's 1, 2, 3 out. It's 3 is our x coordinate, and it's 1, 2, 3, 4 up, 3, 4. It is exactly what we wanted to do. It says, are either B1 or B2 equivalent to the original A1 and A2? Well, let's recall that A1 was y equaled x plus 1, and A2 was y equaled negative 2x plus 10. If you look, the biggest indicator of what's going on is the fact that the slope here is 1, the slope here is negative 2. Notice these don't even start in the same place. We have a slope of positive 2 here and a slope of positive 3. So none of these are the same, but what I'd like to do is show you what it looks like once they're graphed, and then I think it'll be really 4 different lines. Notice I graphed the A1 and this was A1 and A2. I graphed the A1 and the A2. All 4 of these lines are doing different things, but they have one big thing in common. They have 3, 4 for a solution. Well, made that a little too big. Hold on, let me try that one again. They have 3, 4 as a solution. That's good math.